All right, we've been working on graphing trig functions, particularly sine and cosine functions. And last time we talked about the sine pattern, which is this, and the cosine pattern, which is this one. And these patterns are patterns for one cycle of the sine and the cosine function, and we can use them to help us get a really nice graph. And once you can work with the function and determine where these 5 points go, you can repeat that pattern to fill whatever your coordinate plane size is and get a really nice sinusoid from using these 5 points. Last time we focused only on our vertical changes to the function, so we worked with amplitude changes. Those came from the a, which is the constant multiplying the sine and the cosine. And then we also worked with vertical shifts, which they come from this k value at the other side of the function, and we talked about how they shift. These k values will shift the midline of the function up and down. So those were the vertical changes to the function. Today we're going to focus on the b and the h in the equation, and they are both horizontal changes to the function. So I want to show, I want to show you this graph that shows you what happens when that h value changes. So here's a function. Let me zoom out a little bit. This is showing the function 3 times the sine of x minus h. And right now I have it set so that h is just 0. And I have one cycle shown in red, or I guess that's orange. I don't know what color it is. So that you can see where that one cycle is. We can change the h value, and as we change it, what it essentially does is let me turn that black one off. It is basically just shifting the starting point of that particular cycle that normally starts right at 0. So essentially we are literally sliding this function to the left or to the right by whatever certain h value is in our function. Now this is just showing you all the, it's just changing the h constantly, so you see that motion. But anyway, so the h value, it just sort of adjusts where you start that one cycle in particular that you focus on first. But then the rest of the function, just continues that pattern from that one cycle. We could look also at the cosine function, and it does essentially the same thing. It just shifts it to the left or right. So we're going to usually just focus on the sine function when we do these horizontal shifts. These types of translations have a particular name. They're called phase shifts. So the function I want to show you first is 2 times the sine of the quantity x minus pi over 4. Well, if we were just graphing 2 times the sine of x, it would look like this, and we graphed them last time, and I think you probably could all graph that without too much trouble. That minus pi over 4 in the equation here by the x, it's essentially just going to move this starting point over by pi fourths. Now this scale is a little tricky that I have here. This is pi right here, and so essentially we have these pi broken up into 4 parts. Each of these is a pi fourths. So this would be 2 pi over 4, which is reduced to pi over 2. This one would be 3 pi over 4. So when we shift it over by pi over 4, it's going to shift to there. So a couple of things to notice. The cycle has exactly the same length still. So before it started at 0 and ended at 2 pi, now it starts at pi over 4 and ends at, 9 pi over 4. So it didn't change the length of the cycle, it just changed sort of that starting point of the cycle. Now, a trig function is never just one cycle. I mean, I guess you could restrict the domain or something. So remember that you need to extend the function and use that pattern to fill whatever space you have. But this is what the function would look like. So you can see the y-intercept is no longer 0. It's now no, approximately -1.5. So let's try a couple of graphs. So this first one is f of x equals the sine of the quantity x minus pi over 2. So we're shifting our function to the right by pi over 2. So I didn't on this first function change the amplitude or the vertical shift or anything. I wanted to keep it basic first. So we have our midline at 0. That's not going to be shifting up or down this particular time. So normally our function would start, our sine function would normally start right here. But because of the phase shift, it starts instead right here at pi over 2. Now the length of our one cycle is normally 2 pi. The period, let me write this down. The period of the function is 2 pi. So normally that cycle has the length of 2 pi. So normally we would have said our ending point was here, but you can't just shift the beginning. This is also shifting the end of the cycle by pi over 2. Now once you get the beginning and the end point, you can just start cutting it in half like we did last time. So halfway in between these 2 points is going to be this point. Now we have our 3 zeros on the midline, and now we can use finally the amplitude. And I didn't adjust the amplitude of this function, so it's the same as our base function, it's just 1. So between these two, up 1, between these two, halfway down 1. So here is one cycle of the function, and then we can just repeat that pattern to fill in the rest. The domain of this function, like all sine functions, is all real numbers, and the range is from -1 to 1. Let's try another one. Now this axis is in degrees, so instead of radians this time we'll be dealing with degrees. So we first look for our phase shift, and it's going to be moving left by 45. So again, our midline is still at 0 since it doesn't have a vertical shift or anything. And normally our function would start, our sine function normally starts right on the midline on the y-axis. But this one is shifted to the left 45, so it will start here. Now the period in degrees, you'll remember, is 360 degrees. So normally this cycle would end right here, but for this one, it's moving to the left 45. So we now have the beginning and end of one cycle. If we cut that in half, we'll get our other point on the midline. And now finally we'll use our amplitude. The amplitude of this sine function is just 1. So halfway in between these 2 points, it goes up. Halfway in between these 2 points, it dips down to its minimum. So here's one cycle of our function, and we can repeat that pattern to fill in the rest of our axis. The domain is all real numbers, and the range is from -1 to 1. Good handwriting. Okay, pun of the day. Math puns are the first sign of madness. That must mean I am crazy. Okay, so now we're going to focus on what that b value does. Now, b is really the only value here in the function that doesn't directly translate to the graph. So k moves the graph up by k units or down by k units if k is negative. A stretches the function by the value a, and it gives the function an amplitude of the absolute value of a. H directly shifts the function to the left or right by the value h. But b, while it does, there's evidence of b on the graph. It definitely affects the graph. The number b doesn't show up, so to speak, on the graph. So here's the graph. Of the sine of x, and you can see I have one cycle shown in red to help you see that one cycle, and this one happens to be in degrees instead of radians, so that's why you see the 225 and the 450. This point right here is the point 360, so that's the cycle begins and ends there. Oops. Lost. Oh, there we go. Okay, so if we change the b value, so b is right here in front of the x. If we change that b value, here is what happens to our graph. Oops, I don't want my keyboard up. What it's doing is it's changing the period of the graph, but not directly. Right now, b is 4.6. When we started, b was 1. So it looks like as b gets larger, the period is getting smaller. And then as we get, now we're decreasing. So as b decreases, it's almost at 4 now. As the smaller and smaller b gets, the longer and longer the period gets. And in fact, when we get less than 1, it starts stretching it out really, really long. So b affects the period of the graph. It's a horizontal stretch. Now b does tell you something directly, but it's something that's hard to use sometimes directly on the graph. What b is telling you is how many times the cycle repeats over an interval of 2 pi, or in degrees 360 degrees. So you can see here's in the blue is shown the sine of x, and b is 1, so that means it has exactly 1 cycle between 0 and 2 pi. The graph in red is the sine of 2x, and that means between 0 and 2 pi, it has exactly 1, 2 cycles. So that's what b is telling you. And it can work great if b is a nice whole number. If there's 4 cycles, you can kind of figure out that there's 4 of them between 0 and 2 pi. But b doesn't have to be a whole number. B can be any number. So what we would normally do, and you can see on this one that the period, since there's 2 of them between 0 and 2 pi, the period or the length of one cycle is pi. So what we normally do is calculate the period using b. And the equation that you can use to calculate the period is that the period is exactly 2 pi divided by b. So b tells you how many, so the length of each one is going to be 2 pi divided by that number. Or, of course, in degrees, that would be 360 divided by b. And that works in both of these cases. We would calculate the period for this first one by saying that it's 2 pi divided by 1, which is, of course, 2 pi. And here we would say that the period is 2 pi divided by the b value of 2, which is pi. So let's try a couple of these to start to get the hang of it. Our first equation is f of x equals the sine of 4x. So I didn't do a vertical shift here or an amplitude change, so our midline is just at 0. And we need to calculate the period of our function. We'll use the equation that the period is equal to 2 pi divided by b. Well, in this case, our b value is 4. So this is the same as 2 pi divided by 4. and that fraction we can reduce to pi over 2. So the length of our period is pi over 2. Now remember, our sign pattern tells us find the beginning and the end. Halfway in between is also on the midline, and then we go up and down by the amplitude at the halves. So our sine function is going to start here. We didn't do a phase shift this time. But now when we do our ending point, instead of ending at 2 pi, which on this coordinate system would be way over here, instead our ending point is going to be at pi halves, because the length of that cycle, the beginning and end, between the beginning and end has a total length of pi halves for that one cycle. Once you have your beginning and end of the cycle marked, cut it in half to find the other one on the midpoint or on the midline, and then halfway in between it'll go up by the amplitude, and halfway in between it will dip down. The amplitude of this function was just 1. So this gives me one cycle of the function, and then to finish graphing it, I just repeat that pattern to get a nice sinusoid. Always on the ends I kind of miss. All right. The domain of the function is all real numbers, like all of our sine functions, and the range in this case is from -1 to 1. Now it's a little bit maybe hard to see on this function, but you can see that we have 1 cycle, 2 cycles, 3 cycles, and then 2 pi would be like right here, or no, it's a little bit farther over. And we have four cycles to 2 pi. And that's where you can see that be directly. But when you're graphing it, I think it's often easier to just calculate the period than to try to figure out how to fit it in the right number. Okay, so here we go. G of x is equal to the sine of x over 2, and then add 3. So this is like 1x over 2. Well, first of all, we have a small midline adjustment here. Our function is shifted up 3, so our midline is y equals 3. So this is the midline we'll be using for our function. And now we need to calculate the period. So the period is 2 pi divided by b. Well, in this case, b is 1/2. 2 pi divided by 1/2 is, well, 2 divided by a half is 4. So this is 4 pi will be the length of our period. The amplitude of our function is just 1, and we're using the regular sine pattern. So we begin here, our cycle begins here. The end of the cycle is way over at 4 pi. This is a long period. Halfway in between, we're still on the midline, and then halfway in between those 2 points, we go up by the amplitude. Halfway in between these, we dip down to the minimum. So we really, on our graph, could only fit that one cycle. It's so long. The domain is all real numbers, and the range is from, I got so used to writing -1 to 1, but this one had an adjustment. The range is from 2 to 4. Bottoms up, remember, on ranges. Okay, one more of these. We have a kind of interesting looking function. It's in some ways similar to the last one we did, but a little bit different as well. This is a cosine for starters. This is the first cosine we've done today. So remember, the cosine pattern is up high, dip down below on the midline, to make a little V-ish shape for the for those 5 points. So our midline on this function is just at 0. It didn't get shifted up or down. It's a cosine, so I know it starts above its midline by the amplitude of 1. So here's our Here's our starting point for our cycle. And now we need to calculate the period so we know where to put the end of the cycle. So the period is equal to 2 pi over b. Well, this time our b value is pi over 2. So as we're calculating, it's 2 pi over 2. Oh, this is like a 1 pi over 2. So the pi's reduce. Pi divided by pi is 1. So we're left with 2 divided by 1/2, which is the same as 4. So our period is 4. So the end of that cycle is going to be at the value 4, 1. So we've got our 2 points for the ends of our cycle. Halfway in between, it's going to dip down by its amplitude, and then halfway in between those, it is right on its midline. And now we can extend that pattern, and here's our cosine. So we really have the ability to adjust the period to be anything we want it to be. And so we can use this to model a lot of different things. That's what we'll focus on next time, is modeling. Okay, so now that we've done examples of all of the different transformations, we're going to try to graph some functions that have some combinations of these transformations. So remember that the two values that multiply the A and the B, those are both stretches. It either stretches the amplitude vertically or it stretches and changes the period of the function. The two values that are added or subtracted, the H and the K, those are ones that just physically move the shape up and down in the case of K, or left and right in the case of H. So we're going to be combining some of these together. So here's our first function, f of x equals negative 1/2 cosine x plus 3. I've put the information down at the bottom in a very specific order. This is the order that I usually think about the function attributes in. And if you think about them in this order, it can usually help you to get a nice graph. And it sort of is the natural way that you want to start graphing it. So really the first thing I think about is, what shape is my function? Well, this is a cosine. I guess maybe shape is not the right word because they're both sinusoids, but this is a cosine. So as I do the cosine pattern, I remember that that's the one that has sort of a V shape, and this one has that negative in front of the amplitude that tells me that this is a reflected cosine. So my 5 points are going to make this pattern, this upside down V pattern. Okay, so now I'm going to think about the vertical shift of the function, or the what the midline is going to be, and this one is shifted up 3. So the midline is at the y value 3. So here's my midline. And then I should think about if there is a phase shift or not. Well, if there was a phase shift, it would be grouped with this x to change in the horizontal direction. So for this function, there is not one. The next thing that you want to think about is the period of the function. Well, the period of this function, the b value is just 1, and that means that the period is 2 pi. We don't have any period changes here, so we just have our regular period of 2 pi. And then finally, you want to think about the amplitude, and that is, in this case, 1/2. So now we can graph it. With a cosine, remember that the amplitude is used right away, so we know that this function is going to start below its midline because it's reflected by a value of 1/2. And so we got this point of our pattern, and then at the other end, over at 2 pi, because our length of one cycle is 2 pi, we can put the ending point for that cycle. So we have this one now. Halfway in between those two, it goes up above its midline by a half. So now we have that one. And then halfway in between on each side, it's going to be right on its midline. Now we have these two. So we've completed our pattern for one cycle. And now whichever space we have left to fill, we could extend that pattern. This one's going to be here. And we can sketch our graph. So here is our cosine function f of x. So the domain of this function is all real numbers, and the range is from 2.5 up to 3.5. Let's try function g of x. So we have g of x equals 2 times the sine of the quantity 45 times x plus 5, and that's all grouped. So what we want to think about first is our vertical shift if our midline changes. Now we would find that over here. So our vertical shift is that there's not one. That means the midline is at 0. Now that note next to where I just wrote that plus 0 tells us that this is in degree mode. We'll have to make note of that in just a second. Also, remember that this is a sine function. So our pattern that we're going to use is our 5-point sine pattern. Starts on its midline. Okay, so now for the phase shift. The phase shift tells me how far the function moved to the left and the right, and you can see from this grouping that x, the starting value of that cycle is shifted to the left 5. So I can go ahead and put my starting point for that cycle right here. Now before I can put the ending point for that cycle, I need to know the period of the function. Period is related to the b value, remember, and the period is, in this case, because we're in degree mode, 360 divided by b. In this case, b is 45. So 360 divided by 45 gives us the value 8. The period of this function is 8. So that means that if this right here is the beginning of one cycle of my function, the end has to be 8 units away from that. 1, 2, 3, 4, 5, 6, 7, 8. Right here at the value 3. Now if I didn't have a phase shift and my length was 8, it would be from 0 to 8. Shifting it, that phase shift, shifting it back 5, doesn't change the length of that cycle. It should still have a length of 8 for that one cycle. Okay, now finally with our sine function, the last thing that we need to use is our amplitude, and for this function our amplitude is 2. So we have the beginning and end of the one cycle marked. Halfway in between, it's again on its midline. Halfway in between those first 2 points, it's going to go up by that amplitude amount. Halfway in between the second 2, it's going to go down. And now we can sketch one cycle if we want, and just extend that pattern if we want to fill our space, which we should. So here's our function. The domain is all real numbers, and the range is from -2 to +2. Okay, now we have the function h of x equals -10 times the cosine of pi over 6 times x. So we first want to think about our pattern, I guess. This is a cosine function, and it's reflected. So our pattern is going to start down low, halfway in between up high, and then on its midline. So we've got an upside down V pattern for one cycle. So now let's think about our midline. Midline would be the constant added to the function. In this case, there is no vertical shift, so our midline is at 0. The next thing I look for is the phase shift to the left or right. That would be grouped with this x here, and so there is also not a phase shift left or right. Let's calculate the period. The period is 2 pi divided by b. So in this case, our b value is pi over 6, which is the same as 1 pi over 6. The pi's reduced, so it's 2 divided by 1/6, which is the same as 12. So the length of one period is the length of one cycle is 12. For cosine functions, remember they don't start right on their midline. Here's the midline. It needs to start below the midline by the amount of the amplitude, so it's going to start its cycle here. And then the end of the cycle will be after 12 units, so over here is going to be the end of that one cycle. Halfway in between, it's going to be above its midline by that same amplitude amount. Halfway in between these points is going to be on the midline. Now halfway in between here would be a value of 3, so I just have to kind of place it in between the 2 and the 4. And halfway between 6 and 12 is 9, so I'll place this one just between the 8 and the 10. So these are our 5 points for our cosine pattern, and we can just extend that pattern. Here's one cycle, and we can just extend that pattern to fill our coordinate grid. Let's see. There we go. There's our cosine. So the domain is all real numbers, and our range is from -10 to 10. Okay, last one to graph. J of x is equal to 3 times the sine of, we've got an x minus 3 pi over 4 grouped, and then from that we subtract 1. So again, think about what your function is. This one is a sine function, so we're going to use the sine pattern. Midline, 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 up. Oh, let's see. Didn't fit. Can't write that high. Midline, 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 up, down. There's our pattern. I do like to draw a pattern to remind me as I'm graphing. Okay, so let's start first with our vertical shift. In this case, our function is shifted. You can see down 1. So our midline is at -1. The phase shift is how far to the left or right it is shifted. This one is shifted to the right by 3 pi over 4. Now we need to figure out the period of our function. The period of our function, remember, is related to our b value, which is the number that would be multiplied in front of this expression. It is just going to be a b value of 1. So the period is just 2 pi. And the amplitude, you can see here, is 3. So we're graphing a sine function. That means it would start right on its midline, and if it didn't have a phase shift, it would be right here, but our phase shift is going to move that to the right by 1, 2, 3 pi over 4. And then the ending point of that cycle, well, normally it would be at 2 pi. The length of the period is 2 pi, but because we have this phase shift, we need to also shift that one by 3 pi over 4 to the right. So this is the beginning and end of one cycle of our function. Halfway in between, it's also going to be on its midline. So for our pattern, we've got those 3 on the midline now. And now finally we'll use our amplitude. Halfway in between, it goes up 1, 2, 3 from the midline. Halfway in between, it goes down 1, 2, 3 from the midline. So here's one cycle of our function, and we can extend that pattern to fill in our coordinate plane. So here's our function. The domain is all real numbers, and the range is from -4 up to 2. Okay, finally, we just want to look at writing some equations from a graph. So if you look at a graph, you can identify all these different transformations, and you can use those transformations to write the function. So remember, the form of our function is going to be a, and then we'll have our trig function, whether it's sine or cosine. We'll have a b, an x minus h potentially, and a plus k. And we may not have all of these values, but we'll have, and this could be a sine or a cosine, but we'll look for these changes on the graph and then incorporate them into the function. So the first thing I usually do is look for my midline and sketch it in, and it looks to me like our midline is here. Now the reason that I look for that first is because looking for that midline can help me decide what the pattern is and can help me decide what the amplitude is. And without sketching it in, it's very easy to make an error on the amplitude and other things. So, and be careful here, our coordinate plane is counting by 2's in the vertical direction. So it looks like our function was shifted up 2. Well, that tells me that when I write the equation, it's going to have a plus 2 here on the end where the k is. So the next thing that I look for is kind of both the pattern and if I need a phase shift or not, because not every function will need a phase shift. So I'm going to look here, and it looks like the maximum value of the function is right on the y-axis, dips down below here, and up here is where it completes one cycle with these two values on the midline. I kind of try to identify a 5-point pattern, and then I can use that to help write the function. Now, I didn't necessarily have to identify those 5 points. I could have identified something else, but that looked like a good choice to me because that allows me to say that there's no phase shift and that this is going to be a cosine function. So we won't have a phase shift because of that pattern that I chose. Okay, so now we'll use the period of the function, or we need to figure out the period of the function. Well, before we used the equation that the period is 2 pi over b. And if we wanted to solve for b, we could do that easily enough. We would multiply both sides of that equation by b. So we have b times the period equals 2 pi. And if we're solving for b, we would then maybe divide by the period. So strangely enough, and the more you learn about math, the less strange this is, we end up with this equation that b is equal to 2 pi divided by the period. I mean, it's very similar to what we started with. It's just that the b and the period sort of switched places. So if we can identify the period by looking at the graph, then we're able to calculate the b value that we need to use in the function. So for this function, I can look at it, and because of that 5 points I identified, I can see that the length of one cycle is 3 units long. So the period is 3. So that means b is equal to 2 pi over 3. And I can use this number in my equation. And since we didn't have a phase shift, we can write it like this. Now, you could have done that same thing in degrees, and you could have said that it's 360 divided by 3, which would give you a value of 120. So you could have put the cosine of 120x and then just indicated that it was in terms of degrees. or degree mode. Okay, the last thing we need to think about is the amplitude. Be careful here. The midline is at 2 and the highest point is at 6. So the amplitude is 4, and I usually like to double check that on the other side as well. We're counting by 2, so 2, 4. The amplitude is 4. So here's our function. F of x is equal to 4 times the cosine of 2 pi over 3x plus 2. One more of these. They're a little intense, I know. The ones on your homework assignment are not as challenging as the two that we're doing in class. Okay, so here we go. Vertical shift. Well, this looks like it has a minimum of 0 and the maximum is at 14. Well, that means the midline is at 7, which on our grid is going to be here between the 6 and the 8. So the vertical shift is that it went up 7. So remember, our function is of this form, a, and then we have a sine or cosine, b times x minus h plus k. We've identified that our k value is that it shifted up 7. Now we look at a phase shift. So I've got to identify a 5-point pattern. Well, the minimum is not on the y-axis, and nor is the maximum, and nor is the midpoint. Or the midline, it's not on the midline on the y-axis. So it looks like we're going to have to use some sort of phase shift here. And so I'm going to identify these 5 points for my 5-point pattern. So because of the 5 points I chose, I am choosing to write this as a sine function. And we could write it as a cosine function as well. But I chose sine. If I'm writing it as a sine function, I need to have a phase shift. I need to know how far over I went to get to the start of the cycle. And it looks like the phase shift is that it went to the right 5. So in my equation, I'm going to incorporate that here as x minus 5. Well, we need to figure out what our b value is. So we need to figure out what the period of our function is. Well, it looks like the period, or one cycle, begins at 5 and ends at 35. So the period is 30. So if we calculate our b value, at this time, let's say that our angles are measured in degrees. We're going to be in degree mode. Let's use that 360 instead of 2 pi. On your homework, you can choose either. On the answer key, I put both, so it's your choice if you want to write the equation using a radian mode or a degree mode. So if b is equal to 360 divided by 30, we have a b value of 12. So we'll incorporate that into the function here. And now the last thing that I need to include is the amplitude. The amplitude tells me how far above and below the midline the function alternates, and you can see that amount is 7. So our amplitude is 7. So we have the function g of x equals 7 times the sine of the quantity of 12 times x minus 5, and then add 7. All right, so that's everything. We have the homework assignment that is due next time, and we'll be working more on modeling with these functions next time in class. Thank you.